Now let's get working on question number 5, which is to come up with an nth degree polynomial function with real coefficients satisfying the given conditions. Let's look at the conditions given to us. It says n equals 3. N represents the degree of the polynomial function, and that is 3. 1 and I are zeros, so the zeros we are going to use to come up with the factors of the polynomial function, and finally f of -1 equals 8. Now this means that whatever polynomial function we come up with, when we plug in a -1 for x, it should give an f of x value or a y value of 8. Now to begin with, what I'm going to do is I'll write out the polynomial function in factored form. All right, I'm going to write out the form of the polynomial function in linear factors, and then we are going to gradually plug in the value, or we will have to plug in or find first, calculate some values, and then come up with the final answer for our polynomial. Right, so let's pull up my pen here. The form of the polynomial function in linear factorization is f of x equals a. A is going to be the real coefficient of the function. It's going to take a real number, and then the factored form is x minus c sub 1, x minus c sub 2, and x minus c sub 3. All right. Now, why did I stop at x minus c sub 3? That's because n equals 3. If you recall, we learned previously that the number of factors, linear factors that the polynomial function will have is going to be equal to the degree of the function. So in this case, n equals 3. So we have 3 linear factors here. Okay, so now we are going to go ahead and try to fill in the values for c sub 1, c sub 2, and c sub 3. A we have to keep till later on to solve for a and come up with a value for it. All right, but let's start with c sub 1. Now these are the zeros of the function. So let's see what information they've given us about the zeros of the function. So they say 1 is a zero of the function. So I'm going to write here f of x equals a times, I'm going to plug in 1 for c1 and write it as x minus 1. And then I is also one of the zeros. So I'm going to replace c sub 2 and write it as x minus I. And then what do I do about C3? Here we have been given just 2 values. I need a value for C sub 3. Now, recall that we learned before that when the polynomial has an imaginary value as a 0, then by default its conjugate is also one of the zeros of the function. So what that means is if I is a 0 of the function, then automatically its conjugate, which is negative I, should also be a 0 of the function. Okay, there's a theorem on that we learned before, and we have to apply that theorem to plug in a value for c sub 3. So since we already put in I for c sub 2, I'm going to replace c sub 3 with negative I. So it's going to be x minus, and then c sub 3 is minus I. All right, so it's minus I. Okay, so minus and minus I is a plus I. So I'm going to rewrite that. Again, I'm going to show every step here, and you should also, when you are working on these problems on the tests. So x minus 1 times x minus I times minus minus is a plus. So the last factor is x plus I. Now we have to go ahead and multiply out these binomials, but we'll do it step by step again. So first I'm going to start with x minus I and x plus I, the two conjugate factors. So we have x minus I times x plus I, and since they are conjugates of each other, I can use the difference of squares formula that we learned way back in algebra in another semester and apply that. So if you recall, let me just write it out here. A squared minus b squared is equal to a plus b times a minus b, right? We had learned this before, and I'm going to apply this for x minus I times x plus I. So just square x and we get x squared, and then minus and then I squared. So I get x squared minus I squared. However, I have to work further on this because I squared is a real number. I squared is not imaginary. I squared is a real number. I squared has a value of -1. So I'm going to write x squared minus I squared as x squared minus -1, which is x squared plus 1. All right, so that's the simplified form of x squared minus I squared, simplified completely. You have to replace I squared with -1. All right. Now, let me just also quickly go over how I came up with -1 for I squared. If you recall, I is equal to square root over -1. When I square the negative square root over -1, I get -1, correct? When you square a square root, you get back your radicand, which is -1 in this case. And that's how I got this -1. And then -1 times negative makes it a positive. So I'm going to write this as f of x equals a times x minus 1 still stays. And then x minus I times x plus I is x squared plus 1. Now I have to work on multiplying out x minus 1 and x squared plus 1. I'm going to use the foiling method, but I'm going to show my work on the side so you can follow along. So we have x minus 1 times x squared plus 1. I'm going to write out the FOIL because it's easy to make a mistake if you're doing everything in your head mentally. All right, so just write it down. It makes things so much easier. X times x squared plus 1 and then minus 1. Take the second term of the first binomial, which is -1 times x squared plus 1. Multiply it out, we get x cubed plus x minus x squared minus 1. And now I'm just going to rearrange this in proper polynomial order. So x cubed, bring the minus x squared first, minus x squared before plus x minus 1. So now I have it in polynomial order. I'm going to write it out as f of x equals a times. So what I did was just I multiplied x minus 1 times x squared plus 1, and I got x cubed minus x squared plus x minus 1. Now the final step is to find a value for a, which should be a real number. Now in order to find the value of a, I'm going to use this condition given to us here, f of -1 equals 8. All right. So what this says is when you plug in -1 into this function, then it should yield a value of 8. All right. So that means when I replace, so f of -1 should be equal to f8 when I plug in -1. So I don't know the value of a. So let's do this. A times, and I'm going to use a different bracket here because there are going to be more brackets within brackets. X cubed, I'm going to plug in -1 into this x and write it as -1 cubed minus -1 squared. I'm replacing all the x's with -1 plus minus x minus 1. All right. So we have 8 equals a times, now negative 1 cube is negative 1. Negative 1 whole squared is positive 1. Positive 1 times negative 1 is negative 1 minus, oh sorry, I should have replaced that x with a negative 1. So let me do that here. Minus 1. So plus times minus 1 is a minus 1 and another minus 1. And when we add up all these negative ones, we will end up with 8 equals a times negative 4, and rewrite this as 8. All right, let me do that here. 8 equals negative 4a. Now we can solve for a to get a value for a. So a will be equal to 8 divided by negative 4, which is negative 2. So we found a value for a, correct? So we divide both sides by negative 4, right? And we get negative 2 for a. So in the final answer, we have pretty much completed the work. All we need to do is write out the polynomial completely in its entirety, plugging in the value of a into this form here. All right, this is the form we need. We need to see the polynomial in terms of x. So my final answer is going to be f of x equals, plug in negative 2 into a. So negative 2 times x cubed minus x squared plus x minus 1. And that's it. All right, we have completed the working out the polynomial using these given condition. If you want, you can multiply out all these terms with negative 2 and write the polynomial in the final step, but this is good enough for 100% of the points, right? Let's get working on question number 6, which is an application problem on quadratic functions. I'm going to first read through the problem and then I may break it up in parts and reread it to understand what they are asking for. It says here, an object is propelled vertically upward from the top of a 80-foot building. The quadratic function s of t equals negative 16t squared plus 112t plus 8t models the ball's height from above the ground, s of t in feet, t seconds after it was thrown. How many seconds does it take until the object finally hits the ground? Round to the nearest tenth of a second if necessary. Okay, so let's just read the first sentence and try to understand what it is about. It says here, an object is propelled vertically upward from the top of a 80-foot building. So what I'm going to do is draw a rough sketch. Okay, so we have the ground and there's a building rising above the ground to a height of 80 feet. So the height of the building is 80 feet. And then they say an object is propelled vertically upward from the top of the building. So there's somebody throwing an object up. All right, so when you throw an object up, of course, it's going to go up to a certain point and then it's going to turn around and land back, correct? It is going to come back to the earth, to the ground. Okay, so that much we understand from the first sentence. We got a picture before us. Then it says the quadratic function s of t equals negative 16t squared plus 112t plus 8t models the ball's height above the ground. Now let me write the function first. So it says here s of t equals negative 16t squared plus 112t plus 8t. Right? What is S of t? S of t gives the ball's height above the ground. So that means that when we plug in values for the variables here, t, into this function and evaluate it, we will come up with a value S of t, which represents the height of the ball above ground. Height above ground. That's what S of t represents. What does t represent? It represents time in seconds. All right. So that means we can plug in different values of t into this function and it will return the height of the ball above the ground. The question is, how many seconds does it take until the object finally hits the ground? So that means they're asking us for the time, how many seconds. So we have to solve for t in this equation. All right, that's what the question is asking, to solve for t. How long will it take for the ball to come back to the ground after it is thrown? All right. Now, before we go about solving this equation, we have to plug in a value for S over t. We have to, this left-hand side must take a value, correct? Otherwise, we will not be able to solve this equation. So what value should I plug in for S of t? Now, the question is asking until the object finally hits the ground. So it wants to know at what time, not at what time really, but at how many seconds, how long after it is thrown will it come back to the ground. So at the ground, what is the height of the ball going to be? It's going to be 0 feet at the ground. All right, at the ground, the height is 0 feet. All right. So when the object is sitting on the ground, then it's not above the ground, it's on the ground. So the height, it does not have any height above the ground. All right. So it's going to be 0. So I'm going to substitute 0 for S of t and rewrite this function minus 16t squared plus 112t plus 8t, which is now a quadratic equation with one side equal to 0. So we have to solve for t. We can either use the factoring method, or we can, if it's not factorable, then we can just use the quadratic formula. Now, let's see if there is anything common that we can factor out, because these numbers are pretty large, these coefficients. We see that minus 16 is common to all three terms. So I'm going to factor out minus 16 from this trinomial, and within brackets I'm going to have t squared. Now, for the next one, 7 times negative 16 is 112. So, however, if you factor out a negative sign, then the sign inside the bracket will change. So we'll have minus 7t, and then plus 80 divided by negative 16 is negative 5. So I'm going to write negative 5. Okay. So now we have 0 equals negative 16 times t squared minus 7t minus 5. I want to get rid of the negative 16, which I'm going to do by dividing both sides by negative 16. So what happens? This negative 16 divide to 1, and 0 divided by any value is 0. So the left-hand side is a 0. And we have t squared minus 7t minus 5. So we have a simplified form of the quadratic function now. So let's see if now we can factor this. This is not factorable. We cannot find factors of negative 5 that will add up to negative 7. So we have to use the quadratic formula, which is x equals minus b plus minus square root over b squared minus 4ac over 2a. We have to use this formula, but we'll first have to find out identify what the values of a, b, and c are. So a is positive 1, which is the coefficient of the first term, b is negative 7, and c is negative 5, correct? So we have our values now for a, b, and c. Let's plug it into the formula. So negative of negative 7, correct? B is negative 7, so negative of negative 7 plus minus square root over b squared would be negative 7 squared minus 4 times 1 times c is negative 5 divided by 2a. 2 times 1, right? A is 1, so 2 times 1. So negative times negative 7 is a positive 7 plus minus within square roots or under the square root sign we have 49 from negative 7 whole squared minus 4 times 1 times negative 5 is a positive 20 divided by 2. So we will end up with x equals 7 plus minus square root over 69 divided by 2. So we are going to get two values of x. One when we do subtraction, 7 minus square root over 69 over 2, and the other one is 7 plus square root over 69 plus 2. Let me just write this, has become a little bit messy. So this is going to be a plus minus, all right? So I'm going to use the calculator now to do 7 minus square root over 69 divided by 2. Let's see what we get here. Let me clean this up. So 7 minus square root over 69 divided by 2 is negative 0.653. Let me write that down. Negative 0.653. And then the other x value, this is one x value. The other x value is going to be when we add square root over 69 to 7. So 7 plus square root over 69 divided by 2 is 7.653. All right, 7.65. So 7.65. Right, 7.65 is the other solution. Now, you have to stop and think here. Minus 0.653 for time doesn't make any sense, right? It's not applicable. So this is not a solution. Okay, this cannot be a solution because we cannot have time as a negative quantity. Therefore, 7.65 seconds is going to be our only answer for this question. So the way you're going to answer this question is the object will land. Okay, your answer in full sentence form is the object will reach the ground 7.65 seconds after it is thrown or propelled or whatever is thrown. Okay, so that completes this word problem here. Now the last question on the project is on rational functions, as we can see. So let's go through the questions pertaining to this particular function, which is f of x equals x plus 2 divided by x squared plus x minus 6, given that x is greater or equal to 0. The first part of the question says determine the symmetry of the above function. Now, what is the process of finding the symmetry? And before that, remember there are two types of symmetries possible. One is symmetry about the y-axis, and the other one is a symmetry about the origin. All right, so there are two kinds of symmetry possible. Now the last question on the project is on rational functions. So let's go through the function and the follow-up questions related to it. It says the function is x plus 2 divided by x squared plus x minus 6 for x greater or equal to 0. The first question says determine the symmetry of the above function. Now recall that there are two types of symmetries possible. One is symmetry about the x-axis, about the y-axis, and the other one is symmetry about the origin. Now, how do we find out the symmetries? We plug in negative x into the function and evaluate it. All right, so first I'm going to just evaluate the function, plugging in negative x wherever there's an x. So replacing the x with negative x, we have negative x plus 2 in the numerator. In the denominator, we have negative x whole squared plus negative x minus 6, which gives us negative x plus 2 over x squared minus x minus 6 is the resulting function when we substitute negative x into the original function. All right. So now how do we figure out whether there is a symmetry at all or not? For the y-axis, we must see, after plugging in negative x, is the resulting function the same as the original function? Clearly, it is not, because the first x in the numerator, the first term, is a negative x, whereas in the original function, this x in the numerator is a positive x. So it's not the same function. So we know there's no symmetry about the y-axis. What about the symmetry about the origin? Now, for that, we have to check if all the signs in the resulting function have flipped. All right. So we see that, yes, for the first x in the numerator, it was a positive that has changed to a negative x. However, the next one is a plus 2. That sign hasn't changed. And the same thing in the bottom also. In the denominator, x squared hasn't changed the sign. Plus x has become minus x, that's fine, but minus 6 hasn't changed its sign. So that means it's neither symmetrical to the origin. All right, so the answer is no. It does not have any symmetry. Does not have a symmetry. But you have to show your work, how you came to that conclusion. All right. Next one says find the y-intercept. All right. So at the y-intercept, keep in mind the x value is always a 0. So all we do is we plug in 0 into the function and evaluate and see what y value we get. So we have f of 0 will be 0 plus 2 divided by 0 squared plus 0 minus 6, which is 2 over minus 6, which is negative 1/3. So the y-intercept is negative 0 comma negative 1/3. So we got our y-intercept. The next one says find the x-intercept. Now at the x-intercept, the y values are 0. So what we have to do is we have to make the y equal to 0 and solve for x. In other words, we are solving for x in the equation. So what was our equation? It was x plus 2 divided by x squared plus x minus 6. Now I'm going to surround it with brackets. Okay, and equal to, we have to make the other side equal to 0. So first we have to get rid of this x squared plus x minus 6. We have to remove the denominator and make it an equation without a denominator, right? So to get rid of the x squared plus x minus 6, we multiply both sides by x squared plus x minus 6. So they divide on the left hand side. We have to do the same thing on the other side, which is an x squared plus x minus 6 multiplied by 0 is a 0. So what are we left with? X plus 2 equal to 0. Therefore, now solve for x. X equals negative 2. So the x-intercept is going to be negative 2 comma 0. So here we have found the symmetry. Well, there wasn't any symmetry, but we answered the question about symmetry. We found our y-intercept. We found our x-intercept. Now the next part says find the vertical asymptote. Okay, so to find the vertical asymptote, what we do is we just take here the denominator, all right, and make it equal to 0 and solve for x. So what was our denominator? X plus x minus 6, all right, equal to 0. Now this is a quadratic equation, so let's see if we can factor this. The factors will be x plus 3 and x minus 3, minus 2 rather, equal to 0. Make each factor equal to 0. So x equals negative 3 and x minus 2 equal to 0. X equals positive 2. So these two are the vertical asymptotes. X equals negative 3 and x equals 2. Vertical asymptote. So in order to find the vertical asymptote, all we do is we just make the denominator of the function equal to 0 and solve for x. That's all we did here. The part E says find the horizontal asymptote. So horizontal asymptote, for the horizontal asymptote, we have to look at the n and m values of the numerator and the denominator, all right, and then come to a conclusion. So we have here, so what was it? X plus 2 divided by x squared plus x minus 6. So let me write that. What was our function? F of x equals x plus 2 divided by x squared plus x minus 6. Was it plus 6? Yeah, right. So how do we find the horizontal asymptote? We have to look at n and m, and then we have to compare them. What is n? N is the exponent of the leading term. Exponent of leading term in the numerator. Leading term in the numerator. What is m? It's the exponent of the leading term in the denominator. So over here, n is 1, right? The exponent of x in the numerator is a 1, so n equals 1. And m, which is the exponent in the denominator, is a 2. So m equals 2. And then we do a comparison. So n is less than m, and when that happens, then the horizontal asymptote is going to be it's going to be the x-axis. All right. Horizontal asymptote is the x-axis or the line which is in equation form, it's a line of y equal to 0. All right. Now we need some additional points before we can go ahead and graph this function. So we will just pick some random points for x and calculate the function to find f of x. All right. So when x is -1, you have to plug in -1 into the function and calculate it. We will be getting -1/6. Now I've done these calculations before and I will leave it to you to perform these calculations, and I pick another value 1. When I plug in 1 for x, I get -3/4 for f of x, and then we can pick another one, 3, and the f of x will be -5/6 when x equals 3. So now we can go ahead and complete the graphing of this function using the y-intercept, the x-intercept, and the asymptotes, right? The vertical asymptotes as well as the horizontal asymptote. Okay, the horizontal asymptotes. So the y-intercept is, let's go back here to find what the y-intercept was, is -1/3. All right, so y-intercept is -1/3. X-intercept was at -2. The vertical asymptote was at -3 and 2. So x equals -3 and x equals 2. And the horizontal asymptote is the x-axis, so y equal to 0. So let's go and first draw our vertical asymptotes with dashed lines. So we use a different color. X equals -3. So I'm going to draw my vertical asymptote with dashed lines. Okay. And the other vertical asymptote is at x equals 2. So let's quickly draw those. The vertical asymptote. Asymptote should always be drawn with dashed lines. Okay. Now y-intercept, that means the place where it crosses the y-axis, is at -1/3. So -1/3 is going to be a point between 0 and -1. So I'm going to mark it here roughly. And then the x-intercept is at -2. That means where the graph will intersect the x-axis, and that's -2. All right. Okay. So, and we have some additional points here, which we are going to use to draw the graph. Now, vertical asymptotes means that the graph is going to rise along the line or fall along the vertical asymptotes, right? So what the graph is going to look like is, here let's connect these points, and it's going to drop on the negative y-axis, and it's going to rise along the positive y-axis. Okay. And then we have the other, you may want to draw the other points also. When it's -1, when x is -1, y is -1/6. So it'll be somewhere here. All right. And then -1, so 1/6 should be here somewhere. And when it's +1, it's -3/4, which is, should have been somewhere here. So the graph, let me just redraw this part. Okay. And then at 3, when it's 3, it's negative, when x is 3, it's -5/6. So somewhere here. negative. Okay, so the graph is going to look like this. Okay. So in part F, we are asked to plot one point between and beyond x-intercept. However, for rational functions, we also have to plot some points between and beyond the vertical asymptotes. All right, because the vertical asymptotes can create several parts. Depending on the number of vertical asymptotes you can have the graph in several parts. All right. So to plot the points, pick any value of x between and beyond the x-intercept as well as the vertical asymptote. So I chose a few values here when x is -1, +1, 3, and 4. And you can choose another one, maybe beyond the beyond the vertical asymptote. All right, to the left of the vertical asymptote. So let's plot the different points we found so far. We have the y-intercept as -1/3. So let me plot that. Well, I think it's better to start with the vertical asymptote. So I'm going to plot the vertical asymptote first, and then we'll go into the y-intercept and the x-intercept, all right? So x equals -3 is one of the vertical asymptote. So yeah, start always with the vertical asymptote. All right, so the one is at -3. There's a second one at x equals 2, which is right here, and the vertical asymptote must be drawn by with dashed line or as a dashed line. All right. And then we have the horizontal asymptote is going to be the x-axis. The y-intercept is at -1/3. So at the y-intercept, the x value is going to be a 0. So it's going to be a value between 0 and -1. So I'm going to mark the point right here. Okay, somewhere here. And then the x-intercept is at -2. So that means it's going to be here with the point where the graph is going to cross the x-axis. And then we will plot these points that I've chosen for x. We have to plug in the x values into this function, and that's how I came up with these corresponding y values. So let's plot that, those points here. When x is -1, y is -1/6. So that'll be somewhere here. When x is +1, y is -3/4. So that's going to be somewhere here. When x is 3, it's 5/6. So 5/6 is going to be close to 1. And when it's 4, it's 6/14. So it'll be somewhere here. And same thing on this side also. All right, just plot, and I'll leave that to you. Just plot some or rather choose some negative x values beyond -3. All right, where the vertical asymptote, the left vertical asymptote is, and find the points, the y values, and plot those points. But overall, this is how the graph is going to look like. So let me complete this exercise here. It's going to go down along the vertical asymptote on the right hand side, and on the left hand side it's going to rise up along the vertical asymptote of x equals -3 all the way up to infinity, and the other two graphs, or the two parts of the graphs are going to go like this, connect the points, and it's going to head closer and closer to the x-axis but won't quite touch it. And the same thing on the left hand side also. This is how it's going to look like. All right, but you have to really plot a few points on this part, on this section of the graph, to find some y values and then connect the points. All right.